This is Forces Problem Set 5, question number 6. I think this is probably the single most important problem in the whole problem set. For each situation shown below, draw a force diagram for block A, block B, and a third for a system that includes both blocks. I see. So first, I'm going to draw all the forces acting on block A. Block A has an applied force by a hand, a normal force due to the table, gravitational force due to Earth, and because the velocity is constant, I know there needs to be a friction force. So let's see here. Normal force, call that a table that it's resting on, and a gravitational force. Now, I actually am aware that those forces exist on block B as well. I'm going to harness the copy paste that I have here. Because block A and B are the same mass, they'll have the same weight, so therefore they'll have the same normal force as well. When I put block A and B together and treat them as one, I'll have twice the normal force. Now let's talk horizontal. All right, so an applied force by a hand on block A. I've got some friction, and I also see an interaction at this boundary between A and B. So, friction, and some kind of interaction. It's called an applied force by block B on block A. Looking at block B, no reason to think the friction would be any different. And this interaction between block A and B that I've shown here, Newton's third law tells me I need to make that same size force, but in the other direction. Now, I know throughout this picture that the velocity is constant, so I need to make an attempt at making these forces look balanced. I'm going to take these two backwards forces and this forwards force and modify it just a touch so it appears balanced. That looks a little more balanced. And then block B has the interaction from block A acting on it. That's a force pair. And it has friction. Block B does not have the hand interacting with it. I think I'm done with that one. Also balanced. And then finally, considering A and B together. So one thing that's going to happen is there is still going to be friction, and there's still going to be an applied force. So let's bring the applied force over first. Oops, I'm out of room. Go there with the applied force. And then now let's talk about friction. I need to balance this applied force, so it tells me this is a bigger force. It's actually the sum total of these two. These forces are also balanced. And when you look at this picture in whole, you notice that you have three separate force diagrams. And the forces in each situation are balanced. And in the final force diagram, you notice that the interaction between block A and block B that we previously saw here disappears on this diagram. Newton's third law interaction pairs disappear when you combine the two objects interacting into one. All three show a balanced forces situation. Block A, constant velocity. Block B, constant velocity. If you had chosen to study them together only, you'd still see constant velocity. Balance, balance, balance. That has been how to answer question 6 from problem set 5.